We are now dealing with a second type of coordinate system, but it's important for us to be able to translate back and forth between Cartesian coordinates and polar coordinates. Notice that we can assume any point in the coordinate plane has an x and a y value, but we also want to be able to describe that with r and theta. Using some of our conventions of trig that we've already discussed, we know that this angle theta, we can determine the cosine of theta as x over r, the sine of theta as y over r, and the tangent of theta as y over x. Based on those ideas, we come up with these formulas for the conversion. If we have polar and we want to convert to Cartesian, the x value is just the r value times the cosine of theta. The y value is r times the sine. And likewise, if we have Cartesian and we want to convert to polar, then we're going to use r squared as x squared plus y squared, and that the tangent of theta is y and x. Do be very careful to make sure you know what quadrant you're in when converting, and be sure that the polar coordinates fall in that same quadrant. We'll talk about an example here in just a minute. So let's consider converting from polar to Cartesian for these 2 points. If we look here at the polar coordinates, we know this is our r and this is our theta. To calculate our x value, we know that x is equal to 2 times the cosine of negative pi over 3. When we calculate that, we get 1, and we have y is 2 times the sine of negative pi over 3, which gives us a negative square root of 3. So our x, y values are 1 comma negative square root of 3. If we look at a graph of that, puts us down here in the fourth quadrant. And to make sure that that matches, a negative pi over 3 theta would go in that direction with a length of 2. For example B, we're going to follow the same process. X is equal to negative 3 cosine of pi over 4, which is negative 3 over the square root of 2. And y is negative 3 sine of pi over 4, which is negative 3 over the square root of 2. Those two negative values put us into quadrant 3, which puts us right here. And notice the original point was negative 3 pi over 4. The pi over 4 brought us to here, but that negative did indeed take us in this direction. So we recognize we are in the right place. When you are converting from Cartesian to polar coordinates, it's often a good idea to get an idea of where you are first before you do the calculations. If we draw a rough sketch of negative 3, 2, negative 3, 2 is going to put us over here somewhere. So we know that our angle should be between pi over 2 and pi. Since this is pi and this is pi over 2, we know that's where our theta should be. But to get the exact angle, we're going to have the tangent of theta is negative 2 over 3. When we use our calculator and do the tangent, depending on your calculator, you're going to either get the tangent, inverse tan of negative 2/3 is about 2.55 in radians. And again, depending on that calculator, some of them are going to put you in the fourth quadrant of negative 0.59. If that happens, we know we're in the second quadrant. So we either need to add pi radians to this to bring us from here over to here, or we need to make our radius, our r value, negative. In this case, to figure out our r, we're going to use that negative 3 squared plus 2 squared, or x squared plus y squared, which gives us r is 13. So we can write this same point either as the square root of 13, theta 2.55, or negative square root of 13, theta negative 0.59. Either puts you in the same spot right here. Secondly, if we're looking at, and here's the picture there of that point. Our second point that we're going to look at to convert is the square root of 3, negative 1. Again, we know if we draw a rough sketch of that, the square root of 3 is positive. and -1, we're going to end up down here in the fourth quadrant somewhere, which tells us that our theta is between 3 pi over 2 and 2 pi. So our coordinate square root of 3, -1, we can use that to determine using our tangent. So the tangent of theta is the y over x, which gives us -1 over the square root of 3, one of our convenient triangles. So we know that theta is -pi/6. And to determine our r value, we're going to do square root of 3 squared plus -1 squared, which gives us an r value of 2. So we end up with 2 -pi/6. And as you can see from the diagram here, it is indeed in the correct quadrant.